like to introduce our first group. They're going to talk to you about what their project is, but I'm going to make it a little bit easy for them, and I'm going to introduce them. We have Tim Canavan, Joseph Cramsey, and Mitchell Pagriba.
Hello, now you know our names. And our project was the multi-lead mechanical pencil. So, to start off, you ever have too many pencils, too many things, just so many everywhere? This doesn't even work. Just everything always in the way. Too many pencils. Our project condenses that. Now, yes, it's slightly larger than the regular pencil, but you're holding one item that would replace three. Our problem statement was that pencils are widely used in just about everything you do. Every time you need to create something, draw something, work on something, you've got this tool. And it's seen as a tool. From a young age, you pick it up, you use it, it's needed. And as you work in environments like engineering, you may use a lead holder, and you have to use different densities for harder lines, softer lines, and really ghost lines for drawings, drafting, and other creative works that you may want to do. Problems with the current design is that it takes a while to change it out. This carries one lead, and you pop it out, pick up the next one, pop it back in. Our solution will cut that time. The other problem, as I have demonstrated with my lots of pencils and pens, is it takes up a lot of space. When you have a bag of implements, you have a lot of them. And as this already says, the time spent changing them out.
So we figured out some information about what we're going to do through surveys, some of the existing products that are already out there, and various patent searches. One of the problems we had as far as patent searches included the fact that you had some patents that were created but never sold. So that was one roadblock, but we got over that. And through our surveys, we surveyed 200 people. First, we asked if you prefer a pen or pencil. 125 out of 200 people said pencil. So next we asked, how often do you use a pencil? And the vast majority of 152 said 5 or more times a week. And then we asked where the pencil is used, and quite a few use it in drawing, some use it in drafting, but as we were surveying high school students, the majority was writing. And then we found out that there is a preference between wood and mechanical pencil, so to make sure that we still had the same crowd, we surveyed this and found out that the majority of 146 do prefer mechanical pencil.
We then asked if you were to use a mechanical pencil, would you like multiple lead densities? And 90% were 90 were indifferent, 72 said yes, and 38 said no.
Minding our selective pool of where we got this information, we were surveying out of high school, or Wheaton-Warrenville South, as me and Joey are from, and only a small group of them actually went to a drawing or drafting class, so that would account for the smaller slice of our graph.
So then we made a general sample of what we could possibly sell this for, and we still had a lot of the majority around $3 to $2, so we tried to keep our price range around that. And then these are the various patents that we found, which was the clutch pencil, the original mechanical pencil, twist pencil. Here was the decision matrix that we created. A quick note, the one at the bottom was the redesign that came in later in the project. This came in halfway through the trial as a whole. The ones highlighted were what we considered to be solutions that we could definitely go for, as they scored some of the higher numbers. When we got to the revolver design, we went ahead and added it to the decision matrix just for testing reasons where it scored full points.
So our possible solutions included, pardon me. The concept description was we needed a multi-lead mechanical pencil that had a parent piece, which is the main body, and the child, 3 child functions, which would be more of the inner mechanisms housed in here that actually contain and advance the lead. It would need to be very durable, easy to use, ergonomic, and it should exit from a single hole. Earlier in our designs, we had figured one possible solution was to have multiple holes coming out of the main body, but we eventually found a different path. We had found that it should not have an eraser, or, as it is oddly mentioned, a pocket clip, because in our studies, the pocket clip would be broken, missing, or taken off by choice. And in professional usage, we'd found that most people prefer a separate eraser for different tasks, a sharper edge or a duller edge, or something that is able to take up the different densities instead of the regular writing pencil.
These were the changes that came in when we got to the redesign. So we switched out how the mechanisms were put into place. We switched from the slide into place version into the rotate into place. The paler one is the rotating into place version. That's the newer redesign. The orange one is a piece of the old version. The entire outer body in the shell was changed, and we removed the pocket clip, as this new design isn't likely to be put into your pocket as other pencils would be. And it doesn't roll off tables, which was another solution pocket clip was going to fix. In our first design, we needed to make our own extension mechanism, as the size was incompatible with the rest of the shell. So this is how it's going to be put together. You can see the visual representations and blueprints of the parts here where they come together. We were going to have a spring in this area here. That would be the shell that this extension mechanism would be put into. There would be 3 of these in the original design as a whole. That would be a plunger that would push the extension mechanism forward so you can get the lead out. This was the button that extended the plunger. There's the tip. And one of the problems that we found really early on was with the 3D printer. If you tried to get too small when you're printing, then as you can see, there should be a tip there, and it was fused entirely. So we went up a scale, and it turned out looking a little like that for one of the 3 mechanisms. And then we had the new suggestion from 2 mentors. It would have less mass to it, so it wouldn't be so clumsy to write with. The gripping diameter was much smaller, which makes it easier to write with, and you do not need a custom extension mechanism was another important bit, as the old extension mechanism was having a lot of scaling issues.
One thing to point out, this would only be one mechanism inside the initial design. As Joey mentioned, we had to scale it up to get the parts to work, but there would be 3 of these inside of a main body that would select like a multicolored pen, as from one of the patent searches we did. However, we had found that using this concept, you only had to grip this small area when it came down to the actual size. You only had to grip this small area, and it was compact because that was only how long the lead needed to be.
So this would be the outer shell of the redesign.
That would be the inside where the different lead densities were kept. And that would be the piece that would push the lead pieces down.
Additionally, in this design, this piece is also used to dislodge mechanisms, which we'll come back to later.
The cap was actually built to have little ridges onto the bottom of it so that it would fit into here as an L track and turn into place, while also aligning the main hole with the plunger.
So that's when we originally printed out the large scale version. This was for demonstration purposes. There's another shot for the rest of the pieces. Then when we scaled it back down after we found a lot of the kinks, worked them out, the original small scale was just a little bit too small. So we had to scale it up by 0.25. And this is what we have now.
In the redesign, we'd figured that we could actually use pre-existing advancement system. This is actually a modified Pentel 0.7 mechanical pencil mechanism. As I said, there were modifications so that it could actually fit into our model, which was completely designed on Inventor, a 3D modeling software that allows us to put what we have in our minds and from sketches into actual printed objects.
So for future considerations, we'd like to make a third draft of this pencil not using a 3D printer, so we would have more control over the dimensions that would come out of the assembly line that we would have. We would likely use a CNC machine. So we would also need small mechanisms for little kinks that still remain. So we would like our own separate mechanism for getting extension mechanisms out if they got stuck, and another mechanism for keeping the plunger in place as you're writing. We would like to make our own extension mechanism, as we shouldn't be using another company's extension mechanism. And then we would like to improve the selection bit, the mechanism for that as well. So using a pen cam, so when you click it, it slides into place and it's sturdy and it holds there until you click it again.
Special thanks to Mr. Clement, Ms. Johnson, Mr. Helgeland, Mr. Pineda, Mr. Rybinski.
And then these are the sources that we used. And so we would like to open up to questions to the panel, or from the panel.
Mm-hmm.
Nice work, you guys. Can you go over the prototype testing again?
Sure.
We never got around to the testing bit due to the cycle that we went through trying to produce this. Each revision of the pencil took about a week to get through, and there are many revisions as there are many small edits that needed to be made because we couldn't predict the, for example, we would have a wall that was measured to be a certain, whoop, don't feedback. So we would have a wall, stop that, okay. So for example, it really wants to give feedback, I'm really sorry. This would be a set thickness on the 3D model, and once we printed it, it would not be that thickness anymore, as the, I want to say brush head, but it's not actually a brush head. The 3D printer would have a set size, and it couldn't get smaller than that, and so a lot of times we had problems with that, so we had to keep going back and revising.
There would also be like excess plastic inside of older revisions. So with the smaller bits, it would clog up, and
So
things wouldn't function.
Literally just like essentially getting it to work the way you want it.
Yes, sir.
Yeah.
One of Joey's innovations that we'd found were these holes in the side, and this allowed the solution that we put the piece into when it has the support plastic into. These holes allowed it to completely clear support plastic, which we were having problems with earlier.
Good job, guys. Well, despite having the issues with your project, did you guys try to test the prototype by writing using the lenses of your choice?
Oh yeah, it writes.
Yes, we had tested the different lead densities in this model, because this is the closest we have to the working prototype. This is a working prototype. It wrote very well. However, we do not have the system yet to retract the lead into the cartridge before we retract the cartridge back into the main body.
Okay, so we put a tip on at least.
Yes, we were able to put the 0.7 tip on it and have it work and write efficiently and clearly with all 3 leads.
All right, good job, guys.
Yes.
Is that the actual size?
Yes, sir. This was a presentation piece.
Yeah. No
Well,
one's
we
going to be
have-
writing with that.
Well, we have seen pens that have been that size. We opted for the smaller design.
And how did you deal with the ergonomics parts of it? You know that it's comfortable.
We had several people hold it, test it in limited capacities, write with it, because it is the mostly working model.
Okay.
Yes, we found a preferred position. Anyways, so you found a preferred position where you have the part that bulks out here, opposite of this part of your hand. So you found this usually works best, as this way might have a few problems. So we did find that there is a good way of holding this, and your 2 fingers can rest on these 2 flatter planes here.
Another thing we had seen was in the decision matrix, I believe we had, should there be a grip? And while working, as I mentioned, we have these holes in the side, which also double as a grip. It feels kind of comfortable to me, at least. We had seen other people like it, and we went with it. It was
Additionally, in the survey, we were going around asking if if people would prefer a grip for traction reasons or for comfort reasons. It's very split half and half. I know some people just take the grips off entirely, just like they do with the pocket clip. So we decided that if someone wants a grip on there, they could probably fashion one up. So we went with that. Okay. That's it.
okay.
Thank you, guys.
Thank
Great
you.
job.
Thank you for listening.
Gentlemen, well done.